Hello, welcome to Flipped. Today we are on chemical reactions. What we have here is a chemical equation. Okay, A and B are called reactants. C and D are called products. So reactants are what starts the reaction, whereas products are substances obtained by reacting the reactants. So it makes sense to imagine C and D to be pastries or puffs. So if these are the pastries and puffs I want to make, I need the ingredients, which are A and B. So A can be flour, B can be eggs, for example. So as the reaction progresses, the concentration of A and B, will decrease. On the other hand, the concentration of C and D will increase. This makes sense, right? Because as I use up more eggs and flour to make my cakes and pastries, the number of pastries will increase. Makes sense. Whereas the number of ingredients will decrease as I bake more stuffs. I bake more pastries to consume, for example. So this can be likened to this reaction, whereas the reactants will decrease in concentration over time, products will increase in concentration over time. So this is chemical reactions in short. So now we will learn how to determine this whole speed of reaction, how fast this reaction can take place, etc. So we know A plus B giving us C and D, for example. This can be any reactants and this can be any products. This is just a very general formula. So we want to obtain the speed of reaction. That means how fast this reaction is proceeding. We have 3 steps. First step, we measure. We can measure any of the following. For example, we can measure the mass of reactants. Then we track how this mass has changed over the whole course of reaction. We can also track the volume of gas produced, or the temperature change in reaction. This is more for exo and endothermic reactions, which we have talked about in the previous chapter actually. So once we determine what we want to measure, then we plot a graph with the information obtained. For example, in the case of reactants used, the mass and the gas produced, we have 2 graphs here. Let's start off with the first one. So this one, you can see that the y-axis is mass of reactant per gram. Whereas the x-axis is just time per minute, or can be time per second, if the reaction is very fast. But this one just shows you the reaction progresses over time. What do you think the mass of reactant will be as time progresses? As we discussed, the mass of reactants will actually decrease, right? Because we are using up A and B to form C and D. So it can be safely said that the mass will decrease. How much will it decrease really depends on the reactions, and different systems have different rates of decrease. But it's for sure that the mass of reactant will decrease, if the reaction is taking place correctly. So you can see that it just decreases like this. On the other hand, because this is reactants, if it's products, what do you think will happen? It will actually increase in concentration. Makes sense, right? Because as we discussed, this one, A and B, will always decrease. C and D will increase over time. So, but please do take note that this is volume, of gas is only for reaction with gas involved. If I'm using solid or liquid reactants and products only, I cannot measure the volume of gas. This one makes sense, right? Then temperature, there's another way to measure. They'll be using the graphs that we mentioned in the endo and exothermic chapter. Anyway, last step is to finally obtain the speed of reaction at particular instance by calculating the gradient at that instant. So this one is a bit of mathematics. If you want me to go through a video of how to obtain this gradient, we can drop a comment down below to ask me to explain. But I roughly will explain it to you now. Basically, if I have this curve here, then I'll draw maybe at this point I want to measure. At this point in time, I want to measure the gradient. I will then draw a line tangent to this curve here. Let me try drawing a nice tangent. That means it just touches that one spot. And then from here, I can find out the gradient, using some mathematic techniques. So maybe I measure these 2 points and then using the gradient formula. So if you really want to find out how it's being done, you can just leave a comment and I will see whether I want to go through this whole video, of calculating gradient of a curved graph. But in short, this is how we measure the speed of reactants, speed of reaction. Basically, first we measure what we want to get. For example, I want the mass of reactants, and then I plot it out. And finally I obtain the gradient. and then I can obtain the speed of reaction at any instant, at any point of time. Okay, and that'll be all for this first part for this chapter.